I'm going to put this on for people that want to see how to do number one. Let's make sure this shows up. The sum of $12,000. So a total of $12,000 is invested into an annual interest, has an annual interest, so that's going to be our R, but we know we have to write it as a decimal, and it's compounded daily, So how many days in a year? That's what we're always asking ourselves. There is 365. That's going to be our N. And we want to know how much money will be in the account after 10 years. So we want to know this final amount A. I invest $12,000. Now, I do need to say this. If you give me a final answer without actually writing down what the formula looks like, I will not give you credit. So I have 1 plus 0.06 over 365 raised to the 365 times 10. I'm going to grab that graphing calculator. Obviously, all these type of problems you're going to use a calculator with. I'm going to plug this portion in first. 1 plus 0.06 divided by 365 raised to the 365 times 10. And then I'm going to take it times that initial investment of 12,000. And I end up with 21,864.35. This is my answer for number one. Number two says, how much money will be in the account? So I'm looking for this final amount again. If the account is compounded continuously. Now, when it's compounded continuously, most of you like to use this, and that makes sense. I think it's probably an easier formula. I've just memorized one in my head, and I'm going to use 9999 as the end value. We'll end up with the same answer either way. So we have a time of 8 years. We can see what the interest rate is. I do need to turn this into a decimal. So I'm going to move that decimal 2 places to the left. And we know the initial investment. So this is A equals 1,000 times 1 plus 0.0045 divided by 9999 raised to the 9999 times the number of years, which is 8. Okay, I'm going to grab this graphing calculator here. I have 1 plus 0.0045 divided by 9999, and then I'm going to raise it to 9999 times 8. Get an answer and take it times 1,000. Now, when I take it times 1,000, this is what I end up with. I end up with amount of $1,036.66. This is my final amount for number two. How many of you who are working ahead got number two done and you used this formula, but you got the same answer? Good. Did everybody hear that? So you absolutely can use, like was shown in the video, you can use this for this continuously compounding. Or you can choose to use this one, making sure that N is 9999, okay? And we'll learn next year why it's because it goes to an asymptote, right? It's hitting that asymptote. All right, let's look right now at number 3. For those that are working, please. Let's look at number 3 here. Now, here's the difference. We know the final amount. We're looking for the initial. Initial here is our p-value, right? Our initial is our p-value, the principal that was invested. So I know I end up with 8,500. I can also see that we have an interest rate of 7% written as a decimal. It's compounded monthly. There are 12 months in a year. Up above, I'm going to take n times t. So I'm going to take 12 times the number of years, which is 5. I'm going to figure out what this amount is first. I am not going to round it. I don't want to round and then round again. 1 plus 0.07 divided by 12 raised to the 12 times 5. This is this exact amount. To get p by itself, I'm going to divide by that exact number. So I'm going to take 8,500 divided by this number. 8,500 divided by this exact number. And this is what I end up with. I ended up with a principal or initial amount of $5,995.94. Take a look right now so we can get out of here on time. Everybody take your calculator and go second plus 712. Second plus 712. We are going to use the graphing device on our calculator for this. So I'm going to start by plugging this in. 33.33 to get E. I'm hitting the blue button. And then hit our E. Raised to the 0.5493x. Now I need to look at what is going to be our x. X is measured in days. I know we go out to at least the 10th day. There's no negative number of days. I'm going to go out to 25 just to be safe. And now I'm going to hit window and, oops, so sorry. I'm going to hit, let's see, I've done window. I'm going to hit zoom fit. Now, bless you, this represents the population of fruit flies represented by this function. Let's determine the initial population. So if we go second trace and we hit value, we can see this is the initial population. It's always represented by this first number. But here's what we have to go back and read. The initial population, okay, so there we go. We have 33.333. But when we talk about this, let's see how he wants us to exactly round this. Give me 1 second to see how he wants us to round. He wants us to leave it like this, so 33.3 repeating. That's my initial. Now on the 10th day, I'm going second trace, find the value, hit 10. And on the second day, we have 8,098, and he wants us to round to the nearest hundredth. I'll make sure that's known to you so you don't have to try to guess. 0.69 fruit flies. That is part B.